Hello, everyone. My name is Zhenyu, and today I'm going to introduce our AMD software solution for training at scale. I don't know how many people from audience are looking to do the pre-training, post-training, or RL work. From today, we're going to introduce the AMD solution and from scratch. As we know that AMD already scaled to a bigger cluster. We are powering the top 2 supercomputer in the world, number 1, number 2. And about 60% of today's top 10 supercluster are using AMD GPU. And not only for scaling bigger, we are also very greener. So 15 of the top 25 are greener cluster and using AMD solution. And from the frontier cluster on Oak Ridge, they already did some very good job. And they are training the large-scale language model. That's up to 1 trillion model on their GPU cluster. And also, in addition, they did a weather prediction model. It's a vision transformer model. And when it's released, the 100 billion parameter size is the biggest at that moment. And also, they did a very nice job on the AI for Science Foundation model. And then for AI for Science Foundation model, here they use graph-based methodology to do the multitask learning to find a new material through the simulation way to do stuff. And it's because there are different type of characteristic people are looking to find the new material. So there are multitasking that using the hydrogen to leverage the ensemble way to find the newest material that capable of different type of the characteristic. So today, for building a hyperscaler, it's not simply pile up all the hardwares like the storage, like the accelerator, like the network. It needs a well-designed and on different aspect of the data center. So it's combined the communication design, it combined with the storage design, and also the compute together. So you see orchestration at the lower level, but that's not good enough because we are looking for performance and also looking for stability. So therefore, we need a very end-to-end full stack optimization, doing the hardware software co-design, and also doing the top-level parallel strategy and the mid-level kernel optimization and even lower-level stuff together on the fault tolerance design. So here, the answer is that in order to scale efficiently, we need to do a hardware-software co-optimization. Okay, so for Primus, that's AMD's answer to optimizing a time to market for large language model training. And we can see for AI developer, when they start to train the model, they will start to do the scaling experiments and to understand what are the performance I can get from certain model architecture. So it's not only look about the calculation, the performance on the gem. It's also look what kind of memory utilization, right? Can I keep the model within 8 GPU or 16 or 64 or even larger size of the cluster? And what are the scaling when I scale up the parameters and also scaling up the compute, right? So we provide some of the example ready for the most up-to-date open source model like the Llama family, like the DeepSeek family, and also the Grok family as well, and also for a multimodality model. So here we provide the models, scripts, and also tools like to do the profiling, debugging, et cetera, to help our customer to start training. And then during the training, we want to see the performance on the distributed cluster and also training is taking a couple months to do the job, so you are looking to have the stability and the fault tolerance. So here we provide 3 components under the ROCm software ecosystem. One is the Primus-LM. It's doing the large language model training for MFU, the efficiency. And then Primus-Turbo, it's the collection of all the high-performance kernel provided by AMD that we can, in the one spot, you can get all the performance support on the kernel level. And also SaFE is our, the stability and the fault endurance, which means that we provide observability and other capability to ensure it's a successful, smooth end-to-end training process with less fault and less interrupt. And here is one of the whole picture. It involves a lot of exploration here from the efficient side. The Primus-LM provide the parallel strategy analysis and also the best practice we have, and also data set, what kind of optimizer and strategy using, and then what kind of tuning mechanism we provide as well to provide towards a more efficient implementation with a higher MFU. And on the stability side, we provide auto recovery and also an efficient checkpointing loading capability, and also file system together, because for language model, you have a huge amount of training data, as well as for even the diffusion-based model, like the multimodality model, you even have more data. You need to, loading from the storage side to the compute side. So there are a lot of things that we taking care of at this level that we make sure we provide a end-to-end solution. And underneath, there are AMD kernel level, software like the ROCm transformer engine, MI Open, RICO, that's the communication library, and ATER, just the previous session, Jeff introduced the ATER, which is our high-performance, kernel library, and also other stuff. And on the right side, it's the telemetry that during the training, people want to see how healthy is the current cluster and what kind of, abnormal thing that's happening during the training stage. Then we can use those to do some further root analysis. I will have more introduction about different technology in the following slides. But here we show a full example that end-to-end pipelining we cover from pre-training all the way to the RL. And it's our best recipe we will provide to the end user. Here, for LM, Primus-LM, we provide a comprehensive parallelism for most popular models. Here we have, especially today, people are looking for fine-grained MOE model, right? Starting to train that, so we provide a set of the parallel strategy to cover both the dense and MOE model, like the tensor parallel pipeline parallelism, especially for larger model size, you want to go deeper pipeline. And also context parallel for the long context window, expert parallel for using the MOE model, you want to expand, and on the expert on the expert side. And also ETP is the MOE folding that we provide tensor parallel on the attention part and expert parallel on the MOE part, okay, and other technique as well. So together we provide a full set of the support on the MFU side to further improve the efficiency. And also today, because the model is getting larger and larger, and then we have a bigger and bigger cluster to train the model. So you don't want to have a lot of exposed communication outside of the the end-to-end training. You want to further overlapping those. And here we are providing certain technique that you can further overlapping. For example, for tensor parallel, we provide a async way that you can overlapping the gem computation with the all-gather collectives. And in the middle, we provide a even more efficient pipeline parallelism by balancing between different layers, because for MOE model, you have dense layer at the very beginning and then some additional layer at the end. And then you may not have even partitioned pipeline parallelism, but instead we provide a way to have a more efficient way to do that and align with the 1F, 1B interleaving way to do the pipeline parallelism to reduce the bubble. Even we provide the visualization tool, it's also open sourced. You can use that to see how it will on the system level. And on the right side, we also provide a single node solution that we can do CU-free or gather a collective and other type of collective that you don't need to introduce any computation, and further release the GPU for other computation-intensive scenario. And for here, we start to introduce a couple of our experiments that are showing we can strong scale. So for here, if you are in this domain, you know that for strong scale means that we keep the size of the global batch size to a certain number. Here, we keep the global batch size to 128 million tokens, and then we keep the same model, which is using the 2 trillion MOE. Here, the MOE is more like the fine-grained DeepSeek like MOE, and then we do, using 384 as the basic replica, and then gradually scaling to all the way to, mimic to, we have a 32K GPU here. The only thing we didn't measure here is when you have a large DP rank, you don't have all those all reduced at the end of each stage to do the gradient descent. But I think that's only have less than 1% of the end-to-end training. So here we have showing a pretty good scaling, linear scaling all the way up to 32K. But it's not end there. We can keep scaling, but and then there are some noise, up and down. Overall, it's showing 100% strong linear scaling here. And this is another example that we work with the PyTorch torchtitan. Here we show another way to measure how efficient we can scale up. This is a full-size DeepSeek V3 model, has the 671 billion parameters. And this is implemented on torchtitan. The code is available on the public domain. And then what we do here is we scale from 256 and all the way to 1,000 GPU. And here we increase the batch size along increase the number of GPU. And then with less than 4% of the, less than 4% of performance degradation, which is also showing a very good linear scaling. This is on our MI325 GPU cluster. And also, that's for overall end-to-end integration of the performance on the MFU side. On the turbo side, here we want to have a centralized place that for our end user, we can provide a easy-to-use and a collection of all the high-performance kernel that AMD can provide. Right now, we support the front end of PyTorch ecosystem, and we are looking to expand on Jack's side. You can see we can provide different kind of backend to different type of the operator, from HipBlast to ATER to even DeepEP today. We support DeepEP as well. And also, because today people are using a lot of MOE kind of model, so we did a lot of deep customization on top of the MOE package, like the group jam, like the DeepEP solution. And also, in addition, we also provide a low precision FPA training as well. This is another example that we are looking to show that with the DeepEP support, we got the better scaling on the 2 trillion MOE model with 1K GPU. And for this experiments, we did both without and with DeepEP. From left side, the EP size equal to 8, and the middle size, middle two bar is the EP equal to 32, and the right two bar is the EP equal to 64. And you can see without using DeepEP, for each solution, the auto communication starting to consume more and more end-to-end training time. So here we introduce why that happens, because for MOE, you have the routing logic decide each token which expert you will route to, right? For example, for a large MOE, typically you have 256 experts, and only 8 or 16 of those experts will be selected. So the routing logic will decide which 8 or 16 expert will be selected per token. And then you have 8K or 4K training sequence length, right? And then the large batch size. Therefore, you have a lot of auto communication to occupy your scale-out network. But with DeepEP, we have operator-level aggregation, which reduce and sort out all the token where their destination is. And then by leveraging the lower-level ROCm, we provide a efficient auto, we provide a further efficient communication, algorithm. And therefore, you can see that we can keep a constant, close to constant number of percentile on the communication part, which is the orange part of all the charts, and also keep another constant on the compute ratio, as well as the bubble ratio. So therefore, on the rightmost, with EP equal to 64, we have a very good scaling on 1,000 GPU. This is done on the MI300. Okay, so we are talking about a lot of optimization, but today we are also looking to have a very smooth end-to-end training experience. So SaFE is here to provide a three-phase stability architecture. For preflight, we want to validate, quick validate how healthy is the cluster. Is there any bad nodes? Whether my RICO communication working perform well? Are all those gem size, have a good T-flops there, right? So we did a quick minute-level checkup on those, as well as the, the read-write from the high-performance storage. And in flight, we do a real-time monitoring, right? Telemetry, understand how good our current training stage. Is there any loss spike, any other kind of failures or abnormal phenomena that we want to further root cause and relaunch the job instead of keep running on a wrong stage. And for post-flight, we want to further provide a root cause and what kind of failure are there and what kind of thing that we can do further. Are there any hardware failure? Are there any software bug along with this post-flight? And today at AMD, we also doing our own model training. It's Instella model family, fully trained on AMD GPU, and also it's fully open sourced. Here, what we do is that we want to make sure all the AMD software plus AMD hardware working fine for large-scale training. So here we provide a language model family from the Instella base model to the Instella long, which taking care of the long context window, and also Instella math, which doing the deep reasoning part. And also we provide a vision language model, as well as the diffusion-based model text to image. There are more coming out, trained at AMD software stack, and to provide a solution to the end user that we can train at scale, and with all full open source model. And we do have the biweekly Docker release starting from this year. So far, we have covered PyTorch, which is torchtitan, and also Megatron-LM, and also JAX-based training framework, MaxTags. And we support day 0 for a lot of open source model, including OpenAI open source model. And also there are other features that we have. And internally, we have nightly build to find out all the bugs that we should catch up before we release to the public. So a lot of user experience things that are ongoing here. Okay, so Primus is our solution to AMD training software stack. We want to provide a full lifecycle out-of-box experience for our training developer, right? From the training strategy and the system design to training preparation, like the data and other stuff. And also, then you're starting to do the training at scale. Well, you probably will do profiling to understand how good are the performance and ongoing with benchmarking and also other training for stability. And then we cover different kind of model and ecosystem, like the GenAI model, multimodal, and also language model, as well as RAC-6. It's coming soon. So that's a full solution we can provide through Docker-based and also other way to have our end user to benefit from this software stack. Yeah, that's all. Thank you.